everyone, this is Rashik Janjarla. I'm an educator in Unacademy. You can follow me on Unacademy Learning where you can find my other courses as well. In this lecture, we are going to solve an example problem which is based on the nipping of leaf springs. And please rate, review and share the video and also subscribe to Unacademy YouTube channel. In the last two lectures, we have discussed about the design analysis of multi-leaf springs. There we have found the relation for the bending stress and also for the deflections of the two portions of the multi-leaf springs, right? So the concept that we have discussed in the past two lectures will be applied here in solving an example problem. Here we have the example problem. A semi-elliptic leaf spring used for automobile suspension consists of 3 extra full-length leaves and 15 graduated length leaves, including the master leaf. Okay. The center-to-center distance between the two eyes of the spring is 1 meter. The maximum force that can act on the spring is 75 kilonewtons. Okay. For each leaf, the ratio of width to thickness is 9:1, and the modulus of elasticity of the leaf spring material is 207,000 Newton by millimeter square. And the leaves are pre-stressed in such a way that when the force is maximum, the stresses induced in all the leaves are same and equal to 450 Newton by millimeter square. Here we have the condition that when the leaves are pre-stressed in such a way that when the force is maximum, the stress induced in all the leaves are same, which means here these leaves of the multi-leaf springs are undergone the process of nipping, right? In the process of nipping also we have made the stresses in the all portions of the multi-leaf springs or all the leaves of the multi-leaf springs equal to the same value, right? So here we have the problem. Determine the width and thickness of the leaves and the initial nip and also the initial nip preload required to close the gap C, which is called as the nip between the extra full length leaves and the graduated length leaves. So now we are going to apply what we have learned in the past two lectures. Okay. So here we have the required formula is the total number of leaves will be n equals to ng plus nf, where ng is the number of graduated length leaves and nf is the number of the full length extra full length leaves. Okay, where in ng we have the master leaf also included in it. Okay, so we have found the bending stress in the leaves after assembling them under nipping. We have sigma b equals to 6pl by nbt square, right? And the equation for the initial nip is given by c equals to 2pl cube by nbt cube. So the equation of the initial preload is given by pi equals to 2 into nf into ngp by n into 3nf plus 2ng, where p is the applied external load on the multi-leaf spring. So given in the problem, here we have in the problem the maximum force acting on the spring given by 2p equals to 75 kilonewtons, and we have the total length of the multi-leaf spring from I to spring I distance, that is given by 2l equals to 1 meters, and also the relation between the width and the thickness is given by b equals to 90, right? We have the ratio of p by t that is equals to 9:1. Therefore we got b equals to 90. Okay, so the number of extra full length leaves given 3 and the number of graduated length leaves is 15, right? And the modulus of elasticity of the spring material is 20,000 Newton by millimeter square. So we have all the properties needed for the calculation of the parameters given in the problem. Okay, so here we have the maximum bending stress given by 450 Newton by millimeter square. So with the help of these values, we are going to find the values that are asked in this question. So first, width and the thickness of the leaves. To find the width and thickness of the leaves, we have to have the force and the distance and also the relation between b and t. We have force equals to 2p equals to 75 kilonewtons and p equals to 37,500 newtons, right? And 2l equals to 1 meter, that is equals to, on solving for L we have 500 millimeters, and b equal to 90, and we have the total number of leaves in that multi-leaf spring is given by n equals to ng plus nf, that is equals to 3 plus 15, we have got 18, right? So on substituting the value of n in the equation for the bending stress given by sigma b equals to 6pl by nbt square equals to 450. So the maximum load acting on the spring, multi-leaf spring, is 450. Therefore this value should be equals to the bending stress developed in the the leaves of the multi-leaf springs. Okay, that is given by sigma b of this value should be equals to the maximum bending stress that should be applied on the multi-leaf springs. Okay, that's why we have the relation sigma b equals to 450 here. On substituting these values p, l and nb, we have got 6 into 3 say 37,500 into 500 into 500 by 18 into 90 into t square. Okay, we just have replaced the value of width with 90 from the relation b equal to 90. Okay, so on solving for t, we have t equals to 1.56 or 12 millimeters. So we have found the value of t equals to 1.2 millimeters here. So 1.56 is approximated 1.2 millimeters, and from the relation b equal to 90, we have find the value of b, the width of the multi-leaf spring, the leaves of the multi-leaf spring given by 9 into 12, that is equals to 108 millimeters. Okay, so we have found the width and the thickness of the leaves with the relation sigma b equals to the maximum bending stress in the multi-leaf springs that is given in the problem. So next, the initial nip. Initial nip is the distance between the extra full length leaf and the adjacent graduating leaf of the multi-leaf springs, that is given by c equals to 2pl cube by enbt cube. This relation was obtained in the last lecture, right? So with this relation, we can easily get the value of c, the nip, the initial nip of the multi-leaf spring that has undergone the nipping process. Okay, c equals to 2pl cube by enbt cube. On substituting the value of p, l, e and b, t that given in the problem, and also t that was obtained in the past section, we have got the value of c equals to 13.48 millimeters. So this is the distance between the pre-stressed extra full length leaf and the adjacent graduated leaf. Okay, so the value of the initial preload. The initial preload is the value of the force or the loading should be applied on the multi-leaf spring, the leaves of the multi-leaf spring, so that the initial gap c should be eliminated. Okay, so we have found the value of the initial preload pi equals to 2nf ng p by n into 3nf plus 2ng. So with the help of this formula, we can get the value of the initial preload that was developed in the that should be given to the leaves of the multi-leaf spring, so that the gap c can be eliminated. Okay, so on substituting the value of nf ng p n and n on this relation for the value of pi, we can get pi equals to 2 into 15 into 3 into 3 is 37,500 by 18 into 3 into 3 plus 2 into 15, that is equals to 4807.69 newtons. So this is the value of the initial preload that should be applied on the leaves of the multi-leaf spring, so that the gap c can be eliminated. Okay, so we have found the value of initial preload and the value of initial nip, and also the value of width and the thickness of the leaves of the multi-leaf spring. So this is the process to find these values that are asked in this question. Okay, so this example problem is useful to understand the concept that I have discussed in the past two lectures about the multi-leaf springs. Okay, thank you.